Hi students, so let us discuss another important concept in our chapters. Conservation law is direction of final velocities in case of inelastic collision in an laboratory frame of references. So we know that a collision is said to be inelastic if the kinetic energy is conserved. What it is? Whenever if the kinetic energy is not conserved, such collision process is said to be inelastic. But here, in case of inelastic collisions, the total momentum is conserved, but kinetic energy is not conserved. The forces involved in inelastic collisions are non-conservative forces. Okay, so these are the some are few characteristics of inelastic collisions. The examples of inelastic collisions are the bullet hitting a target, or car hitting a bicycle or bike, or truck hitting a car or bicycle, are the examples of inelastic collisions. So here, when that when those two bodies collide each other in an inelastic collisions, some part of initial energy is lost in the form of heat or in what? Sound. So that kinetic energy is not equal to what? The initial kinetic energy of those two outcomes. So that's why the kinetic energy is not conserved in case of inelastic collisions. So here, let us derive what are the final velocities of those two particles in case of laboratory frame of reference. So as I said in my previous class, so the meaning of your laboratory frame is a fixed reference point. So where the positions, velocities and accelerations of the events or the particles or the object is measured with respect to what? A laboratory frame. So such uh, frames of reference are called as what? A laboratory frame of references. With respect to some chosen arbitrary object, so we are measuring in what? Some variables. So that orbits, that frame, so we are calling it by what is laboratory frame of references. Okay. So let us derive what are the velocities of those two particles in your what? Inelastic collisions in the laboratory frame of references. Okay. Consider the two particles A and B of masses m1 and m2. Let the particle of mass m1 moves with an initial velocity u and sticks the particles of mass sticks the particles B of mass m2, which is at rest. So here we have considered and what two particles A and B of mass m1 and m2. This m1 is moving with velocities of what it is here u, and it collides with what? A particle of B having a mass m2, which is at what is rest. So after colliding your particle A with B, so those two particles are what sticks together. That's I have shown. So 1 and 2 is A and B are what collides. On colliding, what happens here? They sticks together. But in case of your elastic collisions, so those two collided particles do not sticks together. But here they collide and stitch together and move it series into what? A single mass and move into what? A single velocity of v here. Okay, so that is the what explanation of that figures. So whatever I have mentioned in the picture. So the same thing I have written here. I have considered what? Two particles A and B of mass m1 and m2. Let the particle of mass m1 move with the velocity u and stick the particles of what? Mass m2, which is at what is at rest. After collisions, so those two particles sticks together and move with the velocity is what is v. Okay. So therefore, what is the uh, now we want to apply that the law of conservation of linear momentum to this event. That's why. So you write m1 u equals to m1 plus m2 close that bracket into v. Means the total linear momentum before collision is equals to what? After collision. So here the second particle is right. That's why the linear momentum of second particle is zero. So you are having what? m1 u1 u only plus equals to what? m1 plus m2 close that bracket into v. So after colliding, so m1 plus m2 they sticks together and move within what? A single velocity. That's the significance of these equations. Okay. So therefore, the final velocity of that particles of those two particles which are sticks together are series into single mass is given by what? V is equals to m1 divided by what? m1 plus m2 is what is into v. Okay. So that is the final velocity of what? Those two stick particles. Okay. Next, let us write what is the component. What is the component of velocity along what is x-axis? The component of velocity along the x-axis. So here, the component here our particle is moving along x-axis. That's why v of x is equals to, again you can write what? m1 u divided by m1 plus m2. But v of y is equals to 0. That means the velocity of the final velocity of those two stick particles is not moving along what? Y-axis. That's why it is 0. Similarly, dz is also what? 0, because those two sticks particles moves along and what? Only x-axis. That's why we're getting what? Vy equals to 0 and vz is equals to what is at 0x. This means both the particles moves together along what is x-axis, and the velocity of the center of mass is also what is v-axis. Okay. Next. So therefore, the position of center of mass, so those two particles is having what? One point where that the entire mass of that object, mass of the system of particles are what? Are concentrated. So that points we are calling it what is the center of mass. So therefore, so for that, the position vector of center of mass with any instant of time t after collisions is given by, and what is RCM is equals to, this is V of x into what? At TIs. V of x into what is at TIs. So here the V of x is nothing but the velocity of center of mass of that particles at an instant of time t, and I is the what? The unit vector along it what is x-axis. So therefore, the position vector of the center of mass at that instant of time t after collisions is given by what? RCM is equals to m1 u divided by m1 plus m2 into what? T into okay. So here there is in case of your inelastic collisions, we know that inelastic collision, the kinetic energy is lost after collisions. That means the total kinetic energy is not conserved. Whatever the total kinetic energy is there before collision is not equal to what? After collisions. Okay, so that means there is a loss of your kinetic energy after collisions. So that's why the kinetic energy. So see here how that kinetic energy after collisions is lost. So kinetic energy of the particles before collisions is equals to 1 by 2 m1 u1 square. So this is the kinetic energy of what? First particles. And whereas the kinetic energy for second particle is 0 because the second particle is at what? Rest. Okay. So therefore, the kinetic energy after collisions is equals to 1 by 2 into bracket what? m1 m1 plus m2 close that bracket into v square. So that's is equals to 1 by 2 m1 plus m2. The value of your v's is what is m1 u1 whole square divided by m1 plus m2 whole square. Okay. So that's is equals to 1 by 2. The value of your substitute the value of is just simplified. So 1 by 2 m1 plus m2 into the what m1 square into equals u1 square. This m1 plus m2, this m1 plus m2, 1 m1 plus m2 get cancels. We are getting out only m1 plus m1 m1 plus m2 you are getting here. Okay. So next is, so divide the kinetic energy after collisions divided by the kinetic energy before collisions. That's is equals to what? M1 divided by M1 plus M2. So after dividing those two quantity, so you will get what? M1 plus M1 divided by is what? M1 plus M2. So which is less than is what is 1. So when you substitute some values here, so that will give you what? Less than 1. When you make it cross multiplications, that indicates what? You just make it cross multiplications. This is equals to less than 1, and then you make it cross multiplications. Kinetic energy after collision is less than what? The kinetic energy before collision is. So whatever the kinetic energy is there after collision of those two particles, so that's what? Less than the kinetic energy before collision. So thus the kinetic energy after collision becomes what? Smaller than the kinetic energy before collision. So whatever is said for the definition of what? Inelastic collisions. A collision process is said to be inelastic if kinetic energy is what? Not conserved. So here, with this equations, so we have confirmed that whatever that kinetic energy is there in case of inelastic collision is not conserved. Okay. So this is what your what? The derivation of what? The final velocities in case of what? Inelastic collision in the laboratory of frame of references. Okay. So, and one more thing, we will discuss what are the velocities of these particles after collisions in the center of mass of frame of references in the next sessions. Thank you.